konsep implicit derivative. Okay, boleh tak? So kalau yang untuk implicit ni nanti I akan share pada Dina lah dia punya solution. Boleh tak Dina?
Boleh doktor.
So itu satu cara lagi lah. Okay, nanti I akan share. Actually sama je. Okay, tapi by using implicit derivative tu dia lagi direct lah, lagi simple dia punya solution actually. Okay, so mana-mana pun tak kisahlah, is either you use chain rule ataupun implicit. Okay, boleh kelas? Okay?
Boleh.
Okay, nanti I share dengan Dina after you punya kelas lah. Okay, next is question number 2. Okay, which group ni? Group 5.
Group saya.
Okay, Dina.
Boleh nampak tak?
Okay, you zoom in sikit. Boleh tak? Okay.
Boleh nampak tak? Dah.
Okay.
Okay. So the question asks a water tank in the shape of upside down cone. So upside down cone means inverted cone. So saya ada lukis dekat sini, cone dia inverted. And then height dia 18 meter with radius 6 meter. Saya pun ada tulis dia punya height and radius. And then dia kata the water flows at constant rate 18 meter kuasa 3 over minute. Yang tu kita tahu dV over dt. So dV over dt is equal to 18. Saya pun ada tulis dekat sini juga. Okay, and then dia tanya how fast is the water level rises when the water in the tank at 4 meter. So maksudnya kita nak cari height. How fast is the water level rises when the water in the tank at 4 meter means dH over dt. Okay, and then that is the keyword lah. Okay, and then saya ada lukis dekat sini. And then keluarkan all the information given. So first kali macam mana kita nak kira, first kali kita kena buat ratio untuk cari R yang new. So R over H is equal to 6 over 18. Yang 6 over 18 ni dia punya yang cone asal lah. Okay, and then cari dia punya radius yang baru is equal to 1 over 3H. And then second step, masukkan formula volume untuk cone and then 1 over 3 pi r square H, and then substitute yang R equal to 1 over 3H ni kat dalam volume of cone punya radius. Okay, and then H dekat belakang ni, kan ada H belakang ni kan. Okay, and then jadikan dia differentiate juga dH over dt macam saya buat dekat bawah ni. Okay, and then differentiate yang V ni, yang volume cone ni, and then dia akan jadi macam ni lah. Include sekali dH over dt yang belakang ni. Okay, then step number 3, dV over dt kita dah tahu dah, tadi ada dalam soalan, which is 18. Dia punya dV over dt tu lah. Okay, and then is equal to yang kita dapat tu, volume of cone tu. Okay, and then bila sekarang ni kita nak cari dH over dt je yang tak ada, and then gerak-gerakkan, bawa pergi sini, and then dH over dt is equal to 81 over 8 pi ms.
Okay, dH over dt 81 over 8 pi meter per second. Macam yang I kata konsep yang what you call tadi implicit derivative tu, macam yang Dina buat ni. So you ada V and H, and then you directly differentiate respect to time kan. Yang sini you dapat dV over dt, and then right hand ni you dapat dH over dt. Okay, ni kita panggil konsep implicit lah. So nanti yang solution yang first question 1 nanti ada. Okay, kalau kita lihat ni, this is volume of cone. Okay, so number 2 ni Dina dah tulis, ada second step, you equate you punya equation of volume for cone. Okay, how to find dia punya R ni, so you ambil konsep ni lah, dia punya cone tu, Means you akan ada two triangle kan. Triangle. The first one is yang size con you tu, radius you punya height 18. Okay, but the question asks you water in 4 meter kan. So yang ni you equate yang number 3 nantilah you gantikan H kita dengan sorry HU mana 4 meter tadi. You ganti tak? Kat mana dia nak? 4 meter right? Okay. Mana you ganti 4 meter tadi kat sini? You punya H tadi kan? Okay, you gantikan dengan 4 lah. So dia punya flow in, okay. Water so kat situ dia ada constant rate 18 cubic meter per minute, which is dVdt. Jadi you rearrange yang ni, you dapat dH over dt. Itulah 80 over 8 meter per second. Okay, boleh tak kelas?
Doktor nak tanya.
Ya.
Dekat step tu kan yang V equal to 1 over 27 pi H cube tu. H tu memang kita kena differentiate sebab kita letak di walaupun kat belakang.
Yes. Jadi you punya buat equation. Okay, kita nak differentiate H with respect to T. So you tengok balik macam mana you punya implicit derivative. So kita for H ni dia kena ni lah H cube ni. You differentiate dia, you akan dapat 3H square. Tapi you punya variable H kita nak actually kita nak T kan. That's why dah dia come up dengan dH dt ni. Kita nak differentiate with respect to T time kita. Okay. Yang ni kita guna konsep boleh tak?
Boleh.
So the rest sama ya dH dt you. Okay, sama ya. Okay, you kena tengok balik konsep yang implicit tu lah. Okay. Otherwise ada juga yang guna apa ni, guna chain rule kan. Kat situ pun ada juga nanti dia terbalik kan. Ada a few students guna chain rule. Okay, kita sama je lah. Okay. Question 3.
Me doktor.
Okay.
Boleh tengok
Okay. Mana you punya solution? Ya.
Alright, so for this question, we're gonna assume let y equal to distance of bottom ladder and x equal to height of ladder leaning against the wall. So we're gonna make use of the theorem Pythagoras formula, which is a square plus b squared equal to c squared, since we already know that the length of the ladder is 20 meter, and we also knew that y is equal to 15 given in the question. So we're gonna get x equal to 5 square root of 7, and we're gonna use the same formula, but then we're gonna differentiate it with respect to t, and we're gonna get 2x dx over dt equal to negative 2y dy over dt. And to get dx over dt, we just have to divide both sides with 2x, and we're gonna get negative y over x dy over dt. Since we already know all the values for the given unknown, we just have to substitute in the digits, and we're gonna get negative 3.4 meter per second. The negative signs indicates that the x is decreasing. Boleh?
Okay. Sekejap. You share balik you punya ni solution. Okay, so kat situ you dapat negatif berapa tu? I tak nampak dah. 3.4. Okay. Negative 3.4. So negative sign here means that you punya ladder dia
Menurun.
kan? Okay, ladder tu jatuh lah, slide down. Okay, so kat sini as you punya ladder tu kita sandarkan pada dinding, dia leaning against the vertical wall kan. Okay. You punya panjang ladder ni is you punya hypotenuse, right? Okay, so punya konsep ni lah theorem Pythagoras you ada x square plus y square equal to ini 20 square. Okay, so dikata kat sini bila jarak antara dinding you punya wall dengan ladder ni dia 15 meter. Okay, what is the rate yang ladder tu jatuh lah. Okay, kita nak cari dx dt. So kat sini you just ganti je lah x kita. Okay, actually yang ni dia dapat 5 square root of 7 kan. Actually dia dapat 13 point something kan. Kalau dia buat kat sini dapat 13 point something. Okay. So equation you actually kat sini x square equal to negative y square kan. Okay, dy dt. Okay, kat sini kawan you dia bawa pergi sebelah ni y ni, and then kita differentiate you punya equation ni with respect to t lah. Okay, so you punya x square you differentiate you akan dapat 2x, so dx over dt lah. Okay, kat sini kita apply implicit derivative concept kat situ lah. Okay, so you just plug in you punya information lah. Okay, you collect information and then finally kita punya ladder tu the slide down at the rate of 3.5 meter. Boleh? Negatif tu sebab dia slide down lah, dia jatuh. Okay, boleh tak kelas? Yang ni boleh ke?
Boleh doktor?
Okay, exercise 3 ni boleh semua dapat sama ke?
Ya, dapat sama.
Okay, alright, question number 4.
Me, madam.
Okay, Hidayatul.
Sekejap. Can you see?
Okay.
Okay, the question is, oil is pumped into a tank of cylindrical shape with radius 5 meter at the rate 8 meters cube per minute. How fast the oil level rises when the oil is at 3 meter head? So for my first step, saya bawa keluar dia punya rate dv over dt, and then the question was dh over dt. So my second step, saya bawa keluar formula cylinder, which is v equals to pi j square h. So saya bawa masuk dia punya radius 5 meter and I got 25 pi h. So for the third step, I differentiate the dv over dt. H dekat sini dia akan jadi 1. So saya dapat 25 pi. And dia dah bagi nilai dv over dt, jadi saya bawa masuk 8. And the question was dh over dt, so saya ubah. And the answer that I got is 8 over 25 pi meter per minute.
Okay, the rest sama tak? 8 over 25 pi meter per minute. Okay, actually ni dia kata you ada tank, okay, bentuk dia cylindrical shape. Okay, kita pump in oil kan? Okay.
Yes.
So kat sini with the radius of 5 meter, okay, this is you punya constant rate lah. Okay, dia pump in dengan rate 8 cubic meter per minute, okay, which is dv dt. Okay, yang ni direct lah, dia nak tanya what is you punya dh over dt when the level oil ni at 3 meter high kan. Okay, so you ambil dia punya volume of cylinder, okay, with the radius 5 ni, you gantikan dekat you punya equation ni, volume. Okay, so apa ni step 3 ni? Step 3, You differentiate both, okay, with respect to T kan. You differentiate V and H. Okay, with respect to T. Okay, lastly, you gantikan you punya dV over dt. Okay, boleh tak? Yang ni direct je actually. Question number 4 ni.
Okay.
Okay, boleh ke?
Boleh.
The rest sama ya? Okay, next is apa ni, graph sketching. How can we sketch apa ni kita punya graph lah. Kita nak cari point dia. Kita nak cari function you decrease, increase, you punya apa ni concavity. Okay, you punya inflection point semua lah. Okay, so exercise 2.2. Okay, number 1, number 2, number 3 ni. Okay, actually dia simple je. Yang tu you buat. Okay, kalau you ada problem, you boleh tanya lah. Okay, so I hope 1, 2, 3 ni you complete on your own. Okay, but question number 4A. Okay, which group ni kelas? Okay, kita discuss yang ni. Question number 4.
Me doctor.
Okay. Nur Syaziatun. Okay.
Can you see my screen?
Yeah. Okay.
So for this question, first we have to find the intercept on the x-axis and y-axis of fx, which is fx is x cubed minus 2x squared plus x plus 1. So in order to get x-intercept, we have to samakan equation dengan kosong. Lepas tu, we simplify, we will get x equal to negative 0.47 and 1.23, which is in the point form, it will be negative 0.470 and 1.230. For y-intercept pula, we have to insert 0 as x into the equation, into the fx equation, and we will simplify, we will get 1, which is in the point form, it is 0, 1. Second, we have to find the interval on which fx is increasing or decreasing. And for this, we have to equate f prime x with 0. So we plug in the values into calculator, we will get x equal to 1 and 1 over 3, which are these two are the critical numbers. And then we have to construct a table to analyze and determine on which fx is increasing or decreasing. We also have to examine the behavior of gradient if value x is lesser than 1 over 3, or it is between 1 over 3 and 1, or it is greater than 1. So for the first interval, I choose 0 as the test value. For the second one, 0.5, and for the third one, I choose 2. And I substitute all of these values into the f prime x. We get for the first interval is a positive value, which means the fx is increasing. And for the second interval, I got a negative value, which means it is decreasing. And for the third value, I got a positive value, that means the fx is increasing. So the conclusion, fx is increasing on negative infinity 1 over 3 and 1 negative infinity or 1 infinity. Meanwhile, it is decreasing on 1 over 3 and 1. And for the third, I have to find the relative maximum and minimum points of f of x. So when x equal to 1, I substitute the 1 into the fx equation, I will get 1. And when x is equal to 1 over 3, I simplify it and I will get 31 over 27. And here is the relative maximum point and the relative minimum point. And then for the fourth
question, I have to find the interval where the graph of fx is concave up or concave down. So for this, I have to equate f double prime to 0, which means I got from the first f prime x, I will get 6x minus 4 equal to 0. And then simplify x equal to 2 over 3. So for this, we also have to construct a timetable, which means the x is either lesser than 2 over 3 or greater than 2 over 3. So for the test value for the first interval, the same as before, I also choose 0 as the test value. And for the second, I choose 1. And then I substitute all of these values into the f double prime x. I will get negative value, which means the fx is concave, the graph of fx is concave down. And for the second interval, I got positive value. That means the graph is concave up. And then lastly, the inflection points of fx. We also have to choose the x of for the f double prime x, which is 2 over 3. And then I substitute this into the original equation, which is the fx1, and I got 29 over 27. So the inflection point is 2 over 3, 29 over 27. And here is the result of my graph. I have already substitute all of the points into my graph, and this is the x-intercept, this is the y-intercept, and this is the relative maximum point, inflection point, and relative minimum point. And I got this shape of the graph for my fx. So yeah.
Okay, so the rest sama tak bentuk graph you? Okay, actually for this function, okay, you tengok for A ni function you punya point actually dia tak beza sangat lah kan. So you punya graph pun tak macam tu je lah. Dia increase, okay, kalau kita tengok sign diagram you, interval where fx is increasing or decreasing kat sini. Okay, the first dia akan increase, and then the second interval dia akan decrease, and then finally dia increase. So since you punya point tu dia dekat-dekat kan, so you punya graph tu tak adalah nampak beza sangat. Dia naik sikit, turun sikit, dia naik sikit lagi. Okay, so kalau kat sini you tengok the first and second interval, okay, the first one dia increase, and then the second interval dia decrease, which mean kat situ you ada relative maximum point lah kan. Okay, so the first and second ni interval, okay, function kita switch, and then ada relative maximum. So relative maximum x kita berapa kat sini? 1 over 3 kan. Okay, so you ganti dekat original equation you, okay, you dapatlah y kita berapa tadi. Okay, so you tengok the second and third interval, okay, they decrease and then they increase kan, which mean you ada relative minimum lah. Okay, and x is equal to apa ni, 1 kan.
Yeah, yes.
Okay, x1, and then you ganti dekat original, kita adalah kat situ 1 you punya point for relative minimum. Okay, next kita tengok concavity. Okay, as you can see here, you punya function kat sini. Okay, dia switch from concave down, and then the second interval tu dia jadi concave up. Okay, so you punya concavity tu dia switch, which mean inflection point exists lah. Okay, so dia exists dekat x 2 over 3. Okay, you nak cari y, you just ganti dekat you punya original equation lah. Okay, finally you collect semua information, collect semua x-intercept, y-intercept, okay, all the point, and then you plot lah atas you punya apa ni, paper graph ni. Okay, boleh tak? Okay, so the rest, ini kita tengok dia tally lah. Okay, first dia increase and then dia decrease sikit, and then finally dia increase balik. Okay, boleh ke yang ni? Okay, so the rest sama dapat ini?
Sama.
Okay, so for question B, Okay, thank you. Sabrina Syahzatul. Okay. Okay, question 4B. Okay, ini which group?
Me, doktor.
Okay.
Boleh nampak tak?
Loading.
Okay, so boleh nampak tak, doktor?
Okay.
Okay, so
Zoom in. Itulah. Okay. Okay. Daniel.
kejap. Okay, so first question ni dia minta cari x-intercept dengan y-intercept. So untuk y-intercept tu kita buat semua variable x equal to 0. Nanti jawapan dia kita dapat y-intercept dia 0, 2. So untuk x-intercept kita buat equation ni equal to 0. Nanti kita akan dapat x equal to negative 7.68 and 0.34. Dan kita choose x dia, x-intercept dia negative 7.68 and 0. Okay, untuk second pula dia minta interval on which function increasing or decreasing. Untuk ni kita buat interval dia daripada, lepas tu kita cari dia punya, kita derive kan dia cari prime, function prime. Nanti kita akan dapat 3x squared plus 14x minus 5. Lepas tu kita, nanti jawapan ni kita dapat x equal to 1 over 3 dengan negative 5. Lepas tu kita buat table ni, kita masukkan nilai dia, interval dia negative infinity to negative 5, negative 5 to 1 over 3 dan 1 over 3 to infinity. So saya ambil test value dia negative 6, 0 dan 6. Lepas tu kita insertkan value dia dalam ni, dalam prime f ni. Nanti kita akan dapat sign dia, untuk dia dapat positif, negatif and positif. So graph dia, bentuk graph dia akan jadi increasing, decreasing and increasing. So function x is increasing in interval negative infinity to negative 5 and 1 over 3 to infinity, while function x is decreasing at interval negative 5 to 1 over 3. Then third, dia minta cari relative maximum dengan relative minimum point for fx. So yang ni kita masukkan dia lah, value x dapat kat sini. Nanti kita akan dapat maximum point dia negative 5 and 77 untuk maximum point. Untuk minimum point dia kita akan dapat 1 over 3 and 31 over 27. So kat sini Ford dia minta concavity untuk graph ni. So untuk concavity ni kita cari dia punya double prime f, dapatlah 6x campur dengan 14. So for interval dia, we chose from negative infinity to negative 7 over 3 and negative 7 over 3 to infinity. And then the test value I chose negative 3 dengan 3. Dan kita masukkan dalam double prime f dia, nanti sign dia kita dapat negative and positive. So nanti dia akan dapat benda concave menghadap bawah and concave up. So nanti kita tulis kat sini fx concave down at interval negative infinity to negative 7 over 3 and concave up at interval negative 7 over 3 to infinity. Then kita cari inflection point dia. Inflection point dia kita substitute balik value dapat kat sini negative 7 over 3 kat dalam original equation. Nanti kita akan dapat inflection point dia negative 7 over 3 and 1055 over 27. So dia bentuk, so saya substitute semua dalam ni, masukkan maximum point dia, inflection point, x-intercept, minimum point dengan y-intercept. Nanti saya dapat bentuk graph dia macam ni.
Okay. So the rest dapat sama tak? You punya function. Sama tak? Ya, you tengok balik, you check lah dia tally dengan the first sign diagram. Okay, the first part dia akan increase and then decrease and then finally increase lah. Okay, so you tengok yang dia ada concavity, the first is concave down and then the concave up. Okay, boleh tak? Nak kat sini. Okay. So the rest sama je kan? Jawapan you. Okay, ada nak tanya ke soalan ni? Question 4. Ada nak tanya tak?
Tak ada. Clear, Doktor.
Clear eh? Okay, thank you Daniel.
Thank you, Doktor.
Okay, next kita pergi pada extremum problem. Okay, for extremum problem. Okay, exercise 2.3. Okay, question number 1.
Me, Doktor.
Okay. Okay, Rina.
Nampak tak?
Okay.
So the equation given is fx equals to 3 minus 2x. So I differentiate the equation and I got -2. And then I find the fx value at -2 and I got 7. And then I find the fx value at 3 and I got -3. So as conclusion, I got absolute max is 7 and absolute minimum is -3.
Okay, so kalau you tengok you punya question A ni, kita tak ada critical number kan jelas. Okay, f prime x u is equal to -2. Okay, which mean you tak ada critical lah kat situ. So kalau you tengok balik untuk extreme problem, kita ada 4 step kan. Okay, so calculate the value of fx at critical number ni, critical point, tak ada lah. So you just ambil you punya n interval. Okay, A kita -2. Okay, B is 3 kan. You punya apa ni? Interval, close interval. Kat situ -2 and 3 kan. Okay, yang ni simple je lah. So the maximum is 7 and then absolute minimum is 3. Okay, boleh Ini?
Doktor, jadi kita biar macam tu je kan yang f prime x equal to -2 sebab kita tak boleh, kita tak ada x lah kan.
Ya, you tak ada X lah. So you just, you buat kat situ lah, you conclude sikit yang kat sini. You tu lah no critical point lah.
Oh, okay.
You note je kat situ. Okay, there is no critical point. Macam tu je lah. Okay. So question B.
Me, madam.
Okay, alright.
Ya Allah, diorang ni nakal lah. Bongok lah, aduh. Tapi gitu Afiq. Kenapa? Takut lah.
So question B,
Takif. Boleh tak you apa? Boleh zoom in? Boleh tak?
the square -3. So first we multiply the x. Then we yes. Can you see?
Okay, Takif. Proceed.
Can you see?
Ya.
We factor x equal to 2 and y equal to -2. So absolute max will get 2 and absolute min will get -2.
Dah habis eh? Okay. So kat sini, okay, what is you punya critical point? I am technical.
Critical point -1 and 1.
So you tengok sini -1 and 1. Okay, what is you punya interval 0 and 1 kan? Okay, you punya interval 0 and 1. Line I okay tak? Okay, and then kita just ignore x equal to -1 since -1 is not in your interval, right? Okay, so you ignore x equal to 1 ni, kita just ambil 1 lah, which mean x equal 1 tu is you punya an interval B kan? Betul tak? So balik F0 dengan F1, you kena ganti ni. You cari f of 0, berapa dia punya value, okay, apa jawapan you, and then f of 1. Okay, f of 0 kita dapat apa kelas? F of 0
0.
0 lah kan? Okay.
You get 0.
0. F of 1 you dapat berapa?
-2.
-2. Which means absolute minimum is -2, absolute maximum is 0.
0. Oh.
Boleh eh?
So that's mean
Doktor.
saya nak ambil yang -1 lah.
-1 you just ignore lah since dia bukan dalam interval. Interval kita just, kita restrict 0 and 1 kan? Boleh tak? Ni ada tadi, last bila semalam, okay. Ada satu student ni dia kata bising, dia kata jawapan final you kan, final answer to solution you tu jawapan dia salah. I check pun memang salah lah. So absolute maximum is 0. Okay. Okay. Yang kat situ tu you punya solution tu dia bagi salah lah kan. So absolute is 0. Okay, kat sini you take note x is equal -1 tu you ignore je lah since dia bukan dalam you punya interval. Okay.
Doktor, boleh ulang balik tak? Tadi suara doktor macam lag sikit, tak dengar.
Oh, ya ke? Okay. So yang this part, okay, you okay tak? I punya nilai. Okay. X is equal to -1 and 1 kan? You punya critical number ni, critical point.
Ya.
Okay, boleh dengar tak? Okay. So -1 ni it's not in your interval, right? Okay, interval kita restrict 0 and 1. So -1 ni tak payah buat lah. So tak payah kira. So you just kira f of 0 and f of 1. Okay, boleh tak? Clear eh? You kira f0, you akan dapat 0. Okay. F of 1, you akan dapat -2. Okay, boleh ke?
So absolute maximum dia 0 lah. Absolute minimum dia -2.
Yes, maximum 0, minimum -2. Okay. Sini 0. Okay, boleh? X -1 kita tak consider lah since dia bukan dalam you punya interval lah. It is not including in your interval kan. Okay. Boleh ke?
Boleh doktor.
Okay, clear ke? Clear tak?
Clear.
Okay. Okay. And then, okay, kita proceed pada C lah. Okay, then question C. Okay, siapa yang buat ni question C?
Saya, doktor.
Okay, Nur Adila. Mungkin sana dulu cik.
Sekejap Nampak tak?
Okay.
Nampak
Yes, tapi you kena zoom.
Nampak.
Zoom
Ya, you kena zoom sikit. Okay.
Okay. Okay tak?
Okay.
Okay, so ni dia bagi fx. Sorry. Ni dia bagi fx x plus 1 over x. So saya differentiate dapat 1 minus x to the power negative 2. And then tu saya cari nilai x which is 1 dengan negative 1. And since both values are in between the intervals, kita substitute both values on fx. So saya substitute 1 dapat 2 and saya substitute negative 1 dapat negative 2. And then saya substitute the intervals dalam fx, and negative 2 dapat negative 2.5 which is the absolute minimum. And then saya substitute 5 fx and dapat 5.2 which is the absolute maximum.
Okay, macam kalau case C ni, kawan you ni, okay, X critical point you akan dapat 1 and negative 1 kan? Okay, so you kena consider both lah, 1 and negative 1, okay, since dia include in your interval kan, negative to 5 ni. So yang ni kena consider lah. So you kena cari the value of F at critical number. Okay, which mean you kena cari F1 and F negative 1. Okay, and then so you tengok yang step seterusnya tu, you kena cari F value at you punya end of interval which is F negative 2. Okay, you punya value A here, and then F of B which is F 5 lah. Okay, so you buat comparison kat sini. So the highest is 5.2, okay, which is absolute maximum. Okay, so minimum berapa? Negative
2.5.
5. Okay, which is absolute minimum. Okay, boleh tak?
Boleh.
Boleh
Boleh.
Yang case yang C tadi tu, since dia bukan dalam interval, yang negative 1 tu, you ignore lah, you tak payah kira dia. Okay, boleh so?
Okay.
Okay, so question D.
Ni doktor.
Okay, Liana. Nanti you tengoklah sambil you buat exercise tu, sebab kita pun manusia biasa kan, kadang-kadang ada silap kat situ. Kalau you macam you rasa solution you dengan kawan-kawan you tak berapa betul tu, tak sama dengan yang answer to exercise tu, you tanyalah. Kadang-kadang
nampak ke?
ada silap jugalah. Okay, you kena zoom sikit. Siapa ni? Liana. Boleh zoom tak? Okay.
So fx equals to x squared minus 2x plus 6. So first we need to differentiate the fx equals to 0.
Liana, can you louder please? Suara you jauh lah.
Sekejap.
You kuatkan sikit you punya suara.
Boleh dengar ke, doktor? Doktor?
Ya.
Okey dah?
Okay. Better.
Fx equals to x squared minus 2x plus 6. So first we need to differentiate the fx equals to 0. 2x minus 2 equals to 0. So x equals to 1. And then we substitute x equals to 1 in the function fx. And we got 5. And also we need to substitute x equals to 1 and 4 in the function fx. So we got 5 and 14.
Tak dengar lah.
Tak dengar ke?
You kena kuat sikit lagi.
Boleh dengar ke?
Baru jelas.
Okay. So fx equals to x squared minus 2x plus 6. So first we differentiate the fx equals to 0. 2x minus 2 equals to 0. So x equals to 1, which the critical point. And then we substitute the x1 into the function fx. So we got 5. And then we substitute x equals to 1 and x equals to 4 in the function. So we got 5 and 14. Then we compare the value of f1 and f4. So 14 is the highest number. So it is the absolute maximum. And 5 will be the absolute minimum.
Okay, actually kalau kat sini you tengok x is equal to -1. Okay, tak payahlah you kira 2 kali. You kira just, you kira sekali je lah. So f of 1 ni, okay 1 ni actually you punya a kan? You kira dekat at end of interval ni. Boleh tak? Okay.
Boleh tak?
Kita kira sekali je lah, since you punya critical point kat sini pun actually you punya interval ni kan, end of interval ni. A kat situ, satu. Kita kira sekali je lah. Okay.
Okay.
Okay, so 5 is minimum and 14 is maximum. Okay. Okay, so yang ni. Okay, next I nak pergi ni, question number 2 ni. Berapa liter ni? Pesticide ni.
Minimum.
Okay, thank you.
Okay, the question is, a graduate farmer found that if he spray X liter of pesticide per hectare, the crop production per hectare is function C. However, the government did not allow pesticide usage of more than 7 liters per hectare. How much pesticide to be used to get maximum amount of crop? What is the maximum amount of crop? Okay, so first step we differentiate the function to get C prime X. So after differentiate, I will get half x squared minus 3x plus 4. So we equal the equation to 0 and we factorize. Then we get x equal to 4 and x equal to 2. So 4 and 2 is the critical point. Then we substitute 4 and 2 into the original equation. We also need to add 7 because the question said that government did not allow pesticide usage of more than 7. So 7 is included. So when I substitute 2 into the function, the answer is 9.33. When I substitute 4, the answer is 8.67. And when I substitute 7, the answer is 17.67. So what is the maximum amount of crop? So the maximum amount is 7 and maximum dia 17.67 times 1000 kg.
Okay, and how much liter yang kita nak guna? Okay, berapa liter yang kita guna?
Yes, Doktor.
Berapa liter kita guna? Untuk kita dapat maximum 17.
Sorry Doktor.
So, kenapa?
Oh, so kita guna 7.
Kita guna 7 liter kan? Okay, actually kat sini
Sebab dekat
dekat mana? Dekat mana Takif?
dekat question dia kata government did not allow pesticide usage. Dekat question macam tu.
Okay, so kat situ dia kata, so dia kat situ you punya interval lah, kita restrict berapa amount of liter yang you boleh guna is between 0 and until 7 lah. So kat sini Thaqif you punya solution ni you tak tunjuk you punya interval kan 0, 7. Close interval 0, 7. Okay, so the maximum 7 lah. Okay, kalau lebih daripada 7 tu government tak allow lah. Okay. So kat sini you punya X, okay, critical point kita adalah 2 and 4, okay, which is dia dalam you punya interval lagi kan. Okay, so you kena kira C at critical number here, okay, 2 and 4, okay, and then you kena cari C at the end of interval, okay, you ada C 7, okay, cuma kat sini you tak tulis lah C0, C0 kena cari juga Thaqif. Okay,
Okay.
actually C0 is 0, 0, 0, 6. Kalau you C0 kita akan dapat maximum crops kita adalah 6 lah. Okay, tunjuk kat situ. So the absolute, sorry, yes.
Kalau saya tertinggal satu step macam saya tak cari 0, so nanti mark saya deduct.
Deduct half. Macam itulah deduct half.
Deduct.
Jadi kalau tidak pun tak banyak pun half ataupun 1 mark. Tapi banyak juga half sikit, situ half nanti kan you dapat full mark lah. Okay, basically macam half je lah, half mark yang kena deduct lah. So kat sini interval pun kena tunjuk Thaqif 0, 7 and then C0 kena tunjuk. Okay, so you punya conclusion ni, okay, so the absolute maximum yang ni which mean 17.67 times dengan 1000 kg is the maximum amount of probes, and then what is the punya liter, kita akan guna 7 liter lah. Okay. So yang dalam kurungan tu X tu dia represent how much liter of pesticide yang you nak kena gunakan.
Yes.
Okay, kena tambah lah 7 liter will be used kat situ. Okay. So the rest,
Interval dia memang kena start dari 0 lah kiranya. Sebab saya buat X 7.
no, kita startkan 0 lah. Kalau kat situ, kat sini, kalau you tengok function u C of X, kata kalau X u 0 kan. So X u 0, dia punya amount of crops you adalah 6 times 100 kg. Okay.
Dia dapat juga. Okay.
Dia dapat juga, contohnya kalau you kat sini buat kalau you tanam something kan, walaupun you tak letak apa baja ke apa ke, dia hidup jugalah, cuma hasil you tak banyak lah kan. Maksudnya macam tu. Boleh tak? Lagi banyak you baja, lagi subur tanaman you, lagi banyak lah hasil you dapat. Tapi kalau you 0 tu maksudnya you tak bagi apa-apa vitamin dekat you punya you punya tumbuhan kan. So you dapat sikit je lah hasilnya. Okay, faham tak maksudnya kat sini? Okay. Kita start dengan 0. Okay, boleh ke?
Boleh.
Okay. So number 2 ni clear kelas?
Clear.
Alamak, actually I nak pergi number 3 tapi tak apalah, sekarang pun dah pukul 12. I think I stop dulu kat sini. Okay. Abang, shh. Okay, kejap. Number 3 ni kita akan continue next week. Okay, so satu group lagi. And then number 4, number 5 nanti I akan explain kat you next week. So nanti petang I akan bagi kat Dina untuk chapter 3. Okay, half of chapter 3 yang you dah cover kan dengan Miss Madam Fiza. Okay, yang tu nanti half of the chapter tu I akan bagi exercise lah in group. Nanti I bagi pada Dina. So next week kita akan start dengan number 3. Okay, number 4, number 5 I akan explain kat you. And then kita proceed pada chapter 3 punya tutorial. Okay, boleh ke kelas?
Boleh.
Boleh
Okay,
Doktor.
and then nanti yang question 1 tu nanti I bagi solution kat Dina sekejap lagi ni. Okay, so I think that's all for today. Okay, thank you class.
Thank you, Doktor.
Thank you Doktor.
Thank you, Doctor.
Thank you, Doktor.
Thank you, Doktor.
Thank you, Doctor.
Okay, thank you. Okay. Okay.
you.